Guys, picking back up with number 19, okay? Number 19, if you look at it, for questions 19 through 20, it says an anagram of a word is a permutation of the letters of that word. For example, anagrams of the word triangle include Griantal, integral, and Tanaugir. Integral is a word, the other ones are not in use, we'll say.
Till someone comes up with a crazy app, Tanaugir. And then we can all Tanaugir each other. Number 19 says, how many anagrams of the word triangle are possible? So we're looking at the word triangle. And they already told us we're looking at a permutation of those letters, right? So we're looking at a permutation of the letters of the word triangle. They want to know how many are possible. Well, if I look at a permutation, how many letters do I have to choose from? I have 8, okay? But how many am I choosing for my word? It's all of them, right? We're just rearranging every single letter. So you're actually doing all 8 letters. Now, guys, the thing you have to ask yourself on this one, probably even before I write this, I should say, is, am I looking at a distinguishable permutation? What would be true about this word that would make this a distinguishable permutation problem? And John, can you please take out the headphones? All right. And no, I'm not taking those today because I don't have time. We got to get through these, okay? Triangle. What would be true about this word that makes it a distinguishable permutation problem?
It's got 3 angles.
Say what?
It's got 3 angles.
Not 3 angles.
That's
It's got nothing to do with what the object is. It's something about the letters in the word.
Can't reuse them. Try. They don't repeat.
Yeah, the letters do not repeat in this. Thank you. Which I think is what you were saying.
Yeah.
If I had a word like, like bullet. Oh no, it's a violent word.
Bullets.
Whatever. I've been playing the game Word Brain, and that's one of the words that shows up a lot. But does that repeat the letter L? Yeah, so that would become a distinguishable permutation problem. Okay? Because if I looked at L being in a word, I couldn't tell which L was where. Okay? So that makes that a different type problem. But this one, none of the letters repeat, so we're doing a straight permutation. And on your calculator, guys, which we talked about earlier, and you'll see this on the video when we watch that, is I want to look at math, but before I do that, I have to put in the first number. So we're going to do 8, and then I'm going to do math, and then I need the probability menu, so I'm going to hit the left arrow, which takes me straight there instead of the right arrow 3 times. And I want this NPR, which is option 2, and then I'm choosing 8 again, and then I hit enter.
This isn't going to be on the test, is it?
I mean, it is reviewed for the test, so.
I'm going to have to use a special calculator.
Okay, 40,320 is your answer. Okay, so you get 40,320. All right. All right. And yes, it is going to be on the test. That's why we're doing this. Okay. All right. Number 21, guys.
21.
Yeah, 21. Remember, you had the odd problems, right?
I won't get that.
Y'all were here for this part.
She was trying to get it.
Okay. A shelf has 10 books, 2 mysteries, 4 romance novels, and 4 mathematics books. If you select a book at random to take to the beach, what is the probability that it turns out to be a mathematics text? Okay, that one you're doing what? What is the probability of X occurring? We said it's favorable outcomes. Okay. Which someone just said, hey, that's going to be a 4. And this is over the possible outcomes. And how many books total are there? You said 10. And then that's going to be either 2/5 or 0.4. Okay?
And you can use both answers, it doesn't have to be one.
Yeah, now when you do your test tomorrow, which by the way, here's another reminder, make sure you have your PowerSchool login. If you do not have your login and you come in and you're like, oh, I can't get on, guess what you're going to get on your test? A 0. Okay?
So how would we get it? How do we get it?
You're supposed to already have it. I've given it 3 times or 2 times at least on your last test, and we had another test, so yeah, at least 3 times I've given it to you. And I told you that the last test, that is the last time I'm giving it to you. Okay? So if you don't have it, I go to the office and find someone that does. Okay? But this is either 2/5 or 4/10. So if you're entering your answer, it's going to be the gridded response. I would just look for, does it got a decimal, or does it have a fraction bar for however you're going to type it in. Okay? So you're either going to grid in 2/5 or 0.4 or 0.4, whatever. So just be aware of that. 23. Let's see what that one says. 23 has multiple parts. You do have some questions on your test tomorrow that have multiple parts. Okay? Those are, in SchoolNet, it's called a task, and you go through and work different parts. I will tell you, the first part of the question, make sure you jot down any information you need off of that. Then it goes to the part A of the task. You know, if you need something off the first one, you need to have jotted it down. Not saying word for word, just any given information. Okay? 23A, it says a coin is tossed 3 times in a row and the outcomes of each toss are observed. Find the sample space for this experiment. Okay, the sample space is what? Is every possibility that could happen by tossing that coin 3 times. Each coin has either what? Heads or tails, which we can represent with H and T. So I can make a list of these. Okay, I can start with 3 heads, and then the next thing I would have 1 tail, so I could put a tail, heads, 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 tails, heads, or heads, heads, tails. Okay, the next possibility is having 2 tails, so I could do tails, tails, heads, tails, heads, tails, or heads, tails, tails. And the last possibility is what? All 3 are tails. So that's my sample space. All right? So if I flip that coin 3 times, the outcome is going to be one of these. Okay? Does that make sense? All right? So part B says find the probability of getting 3 heads. Okay? So if I got the probability of getting 3 heads, that's what? And I can just say 3H for 3 heads.
1 out of 8.
Yes, 1 out of 8. Okay? So that's your probability. And then part C says what? Find the probability of getting 2 or more heads. Okay? So which of these has 2 or more heads?
4 out of 8.
This one, this one, this one, and this one.
4.
So probability of heads being greater than or equal to 2. You said was 4 out of 8, which is going to be 1/2 or 0.5. Okay. So again, I can put 1/2 or 0.5. It's the same thing. All right. Part D says find the probability of getting tails on the first toss. What's the probability of getting tails on the first toss?
Or how many times we toss?
Ouch. What would you say? And how would you justify it? Probability of tails on the first toss.
You look at me. 4 is 1/2.
So you're going to say 4 out of 8? And that's 1/2. Okay. Could I also look at the fact that I'm just tossing a coin?
You only got 2 sides.
It's only got 2 sides. So 1 out of 2. All right.
You're not even gonna have 1/3.
Yeah, you're not going to have 1/3. Okay. All right. Does anyone got any questions on that one?
No, I get it.
You understand sample space? What can happen? Favorable outcome? Or 4?
3 heads. Alright. I'd have 1 out of total 8 possibilities. Alright. If I roll 2 die, what's my sample space total? How many possibilities are there?
12.
Not 12.
6.
It's not 12.
6.
Think about this one, guys. This one right here. If I look at the sample space, but that's 3 coins. It's almost like you're doing heads, tails, and then a third one is going to be heads and tails. So think about a cube with all these different slots, and I could have heads, heads, tails, heads. Do you see what I'm saying? But if I look at just 2 die, then that's going to be what? I have 1 through 6 here, and I also have 1 through 6 here. So looking at a grid of all these possibilities, what's 6 times 6?
36.
There's 36 outcomes. The diagonal would be your doubles, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And then everything else is things that aren't doubled, okay, or repeated. All right. What's the next number? 25. All right, let's read that one. It says, find the probability that the indicated card is drawn at random from a 52 card deck. Okay. So what's the probability that I draw an ace?
4 out of 52.
Yeah, there's 4 aces in the deck out of 52 total cards. So that should be what?
So 4 goes into 52.
I think it's 1 over 13, right? Yeah. All right, 20, I'm sorry, part B. They said, what's the probability of an ace or a jack? Ace or a jack. Okay, do you remember doing the or problems? Can a card be an ace and a jack at the same time?
No.
No. So what am I going to do to those probabilities?
Combine.
You're going to combine them how?
A number of aces and a number of jacks.
Yeah, but how am I going to do that?
4 of each. 4 aces.
We have
So we're going to take the probability of getting an ace and the probability of getting a jack, and you're simply going to add these two together, okay? Because that's an or, and these can't be an ace and a jack at the same time. There's no overlap, okay? There's a special formula if you have overlap. remember? So what's the probability of getting an ace? We said was 1 over 13. What's the probability of getting a jack? Well, that's the same thing, right? 1 over 13. Because there's 4 jacks in the deck as well. And then you end up with 2 over 13 for your probability. Okay? And then if you look at C, C says an ace or a spade. So the probability of ace or a spade. Let me ask you a question. Can a card be an ace and a spade at the same time?
There's one card.
Yes. So do you remember this formula? Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay? Do you see that? See, this ace and jack, I can't be ace and jack at the same time. That's why this goes to 0, and I just add these two probabilities because that intersection is 0. They're mutually exclusive. They don't overlap each other. But the fact that a card can be an ace and a spade, I get that overlap. Okay? And remember we drew the Venn diagram and showed that, if you remember. So the probability of something being an ace is going to be 1 out of 13. The probability of a spade is what? How many spades are in the deck?
13.
How many suits are in the deck?
13.
There's 4 suits in it.
4 suits. So I would assume it's going to be 1 out of 4, right?
Yeah.
Okay. Because that's going to be basically 13 cards out of 52, which is 1/4. Okay. And the probability of A and B, well, that's just the ace of spades. And how many aces of spades are there?
What?
Just 1 out of 52. Okay. So if I add all these up on your calculator, you get what? You get 4 out of 13. All right. All right. Part D says what? A red ace. Oh, Lord. Do I have overlap? Can an ace be red?
Yes,
Yeah.
2 different suits.
So what's the probability of red plus the probability of ace minus the probability of red and ace?
Well, the probability of red, you gotta have the club and, not the club, but the diamond and the heart.
Is that how I'm doing this?
2 out of 52, 1 over 46.
Yeah, I don't think I have to do that though, right? Ignore this. I'm complicating that. I'm mixing my problems. A red ace, guys, that's either an ace of hearts or ace of diamonds. There's only 2 of those out of the whole deck. So again, don't complicate it. And 2 out of 52, I have to simplify that, so I get what? 1 out of 26. Okay. All right. Does anyone have any other questions on this one? Yeah. The 2, a red ace could be the ace of hearts or the ace of diamonds. Okay? So you're looking at 2 possibilities there. And there's only 1 each of those cards, so that's 2 cards out of 52 total cards. And then you just get 1 out of 26. See, I was mixing this up because I'm thinking of being red and ace. And I probably could set it up like that and get the same answer. But that's just complicating it because there's only 2 possibilities out of 52. and it's easier just to write that. Okay. All right. 27. Number 27. All right, 27 says 2 dice are rolled. Find the probability of each outcome. So on part A, you want the probability that the dice show the same number. So that's basically the probability of doubles. And what did we say about that a while ago? How many doubles do you have rolling 2 die?
You got a lot.
It's just 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So just 6 of them. And we said, what's the sample space a while ago of rolling 2 die? We said that's how many? 36? So your probability is just 1 over 6. Okay? And then the last one says, what's the probability of what? The dice show different numbers. Dice show different numbers. Guys, dice showing different numbers is the same as saying what? The probability of what?
1 out of 6.
Not 1 out of 6.
No, there's 2 of them, so 1 out of 36.
What's another way to say that my dice don't show different, or they show different numbers?
If they show, that would be 30.
If they show the same number, it's what?
They show the same number for 2 dots, show the same number, would
That's
be
if
1
you
over
show the same,
36.
it's 1 out of 6.
Yeah, if they show the same number, it's doubles. If they don't show the same number, it's,
Singles.
what's another way to say it?
Singles.
Out a little.
I got
Okay,
2 hours of sleep last night.
think about it like this. I'm trying to get y'all to remember the word, okay? You are either at school or you are what?
Asleep.
Not in school.
Thank you, not in school. I either have doubles or I don't, which is not doubles, okay? So what you're doing is the complement. Do you remember that? So if I do the complement of the event, that's just 1 minus the probability that I did get doubles. See, we've already done doubles, so this is just going to be 1 minus 1 over 6, which is what?
5 over 6.
5 over 6. Okay? So again, on your testimony, think, when can I do a complement of an event? Maybe I do a calculation and the next one is just simply what? It's the complement. If I don't do the complement, I got to look at that sample space of 36 items, knock out 6 of them, and say I'm doing 30 over 36, and then reduce the fraction and blah, blah, blah. Do you see what I'm saying? It's easier just to do the complement, okay? So think about that. Remember that. The complement and the original probability, both of those add up to 1, okay? And sometimes doing the complement is the easier approach to the problem, okay? Number 29. Let's see what that one is. And I guess I got to slide over here. All right, 29 says, in the numbers game lottery, a player picks a 3-digit number. That sounds like one that we play in North Carolina here. 000 to 999, and if the number is selected in the drawing, the player wins $500. If another number with the same digits in any order is drawn, the player wins $50. John plays the number 159. What is the probability? So we're doing a probability calculation that he will win $500.
1 is
Okay, if I'm saying the probability is that he wins $500, that's the probability that what happens? That's his number is selected.
The number
So there's one in, Jesus, how many are there?
If he gets the correct number, he wins $500. Like,
Yeah.
So we're saying the probability that he gets 159.
yeah, okay.
Okay.
That's one in however many there are.
Now, what is my favorable outcomes? How many numbers 159 are there?
One.
I'm sorry. Well, from 000 to 999, how many 159s are there?
One.
Just one. Okay. How do I count up the possibilities here?
You just say,
So you got
ain't it
one.
like,
Wait, would it be? It's,
okay.
it has 1,000.
Yeah. How did you get 1,000?
Because it goes to 999, but it includes 000, so 999 plus 1 is 1,000.
I like that, guys. You know how I did that? I had to go back and use what we did. The fundamental counting principle. 3 digits, 10 choices each. Repetition is allowed. 10 times 10 times 10. You get 1,000. I like y'all's approach. Very good. So that's your probability right there. 1 in 1,000. Okay? Yeah, that was not bad. Now this one, part B, what is the probability that he will win $50? So what probability are they asking you?
Well, you've got to have 5, 1, and 9 in the same.
Like, if the number's in any order, he can win the $50, right?
Okay, so
I'll have to write
if
it down.
another number with the same digits in any order is drawn, the player wins $50.
So even if you get like 9, 51, 55, 19, something.
Yeah, 519, something like that. How many, is that permutation or a combination?
I mean, because you have like a variety of numbers.
Yeah. So permutation order matters, right? And order does matter on a number because that tells you what number it is. 100 and 001 are two different numbers, right? 951 is different than 159. Okay, so it is a permutation. So we're saying any number with 159. Okay? Yeah. And that, how you write that, I'm kind of like, that's a hard one to express simply. Okay, but we're saying if I mix those numbers up, so what's my possible outcomes? Is that still 1,000? Yeah, there's still 1,000 numbers. But what goes on top? I have the permutation of what? 3 numbers. Taking what? 3 at a time? Right? And guys, have they already chosen the number 159? Yeah, so I don't want to include that one, right? Because he's winning the $50 if they pick a number that's not 159, but it contains those digits. So you're going to subtract off 1 here, okay? And then what's the permutation of 3? Taking 3 at a time, that's what? 3, math, left arrow, option 2, 3. So you get 6. Yeah, it's the same ones a while ago. You do your 3, math, left, option 2 is NPR, and 3.
Left option.
Yeah. So I'm subtracting 1, and that's over 1,000. So that's going to be 5 over 1,000, which is what? I know. But listen, what you don't see is I've already shown you the calculator strokes on the last video. You just hadn't watched that video yet. Okay? That's why I didn't take time to write it out, because I've already written it out. Okay? Alright guys, this right here, that piece, you have to be real careful. You have to think about what you're doing. Because yeah, I can find the permutation easy, but guess what? One of those you don't want to include, because that number's already been chosen, and he's looking at winning 50 if anything other than that number is chosen with the same digits. Okay? So you have to remember to subtract that off as a possibility or a favorable outcome. Okay? I guess I'm flipping this over now. Yeah, there we go. So this is what next? 31? All right, 31 says what? 2 dice are rolled. John gets $5 if they show the same number, or he pays $1 if they show different numbers. What is the expected value of this game? Again, we looked at expected value problems yesterday. So again, you're going to make your list of outcomes, which is X, and what's the probability of X occurring? And one probability, guys, is John gets $5 if they show the same number. Okay? So I get plus $5, which is kind of nice. What's the probability if they show the same number? Didn't we just do those probabilities? We said the probability of doubles is 1/6. Okay? Can y'all see that? We calculated that probability a while ago. And we're saying you gain $5 if that outcome occurs. And then the other one is, I think you lose $1. He pays $1 otherwise. So that's going to be minus $1. And what's the probability? Well, that's if none of the dice show doubles. They don't show the same number. So we said that was 5 out of 6. Okay? And then the expected value of this game. So you're going to write E of X. And we said you take each of these and take the product, and then add them. So you have $5 times 1/6 minus $1 times 5/6. So that's basically 5/6 minus 5/6, which is 0. Is that a fair game? Yeah, expected value 0, that's a fair game. Okay. Alright. And that just simply means if I play this game repeatedly, then I'm going to come out with an average of 0. Okay? So if I win the first time, I might want to stop there. If I keep playing, I'm probably going to get less and less and less money that I've gained until I'm down to 0. Okay? Alright. 33. Yeah, this is expected value, I'll say. It says Mary will win $1 million if she can name the 13 original states in the order in which they ratified the U.S. Constitution.
You gotta know the history on that.
You don't have to know the history, but it would be nice. But Mary has no knowledge of this order, so she makes a guess. That's kind of like people doing the what?
Lottery.
Not the lottery too, but I'm thinking of something else. What happens when the NCAA and the ACC roll around?
What do you call it? The bracket.
The bracket. People don't know what the outcome's going to be, but they guess. And they may or may not win, right?
Yeah, you know what shit you're talking about.
And I think before you play something like that, isn't that illegal in North Carolina?
Kind of like bracket.
Just so you know,
What's illegal?
doing the brackets and like gambling with it. I think that's illegal in North Carolina.
It is, in fact.
Yeah, I'm almost
We
positive.
did that in middle school. They passed out the bracket.
Play a card.
Yeah, you can pass out the brackets and choose stuff, but when you're gambling with it and people put money in a pot, that's kind of illegal.
Why can't people do what they want to do with their money?
So,
Why can't people do what they want to do with their money?
because we have a government that tells us otherwise.
Because America is turning into a communist state slowly but surely.
All right, guys. No, that's a discussion for another day because we got to finish these.
13 times.
So what's her expectation? So we are doing expected value. So we need to write out what are the possibilities, okay? The outcomes, X, and the probability of X. Can she win $1 million?
Yeah.
So that's gaining.
She can.
Is she going to lose anything?
No.
No. So 0. What's the probability of getting the $1 million?
1 out of 30.
She's got 1 out of how many possibilities? If I arrange those 13 states, does the order matter?
Yeah.
Yeah, they tell us it matters. The order in which they're ratified.
You can't reuse
That means I'm doing a permutation or a combination?
combinations.
Combination. No.
You can't use the same number of the same statement.
Exactly. But if I do a combination, it's just one. It's the same 13 states, the same group. Because I'm taking all 13 at a time.
I was just trying to choose one to maybe go like 13, 12, 11.
No, it's going to be a permutation. Okay? So you're going to do a permutation of 13 states, taking 13 at a time. I'm sorry. So that's going to be 1 out of whatever this is. 13 math, left arrow, option 2 for NPR, and then 13. Is that a big number? Yeah, that's a pretty big number. So we're going to write 1 in 6227020800800.
What number is that?
And guys, I'm going to multiply this probability times this. So my expected value is this number, but I'm going to flip it over, which I can do with this key, x to the minus 1. That inverts the answer. So that's 1 over that answer times 1 million.
Hey, that's the possibility.
And I hit enter, and I get 1.606 times 10 to the minus 4. That's sad.
You do that on paper, Mr. Young, without having this calculator?
Oh yeah, you can try and do it on paper.
But how would you go about doing that?
Oh, I'll let you figure that one out. You have fun with that too. This is 1, 2, 3, 1, 6, and that's dollar amount. Is that a lot of money you're expecting?
Well, it's more than you had because you didn't have to do it.
Yeah, but that's pretty a small payout expected.
I mean, if you know the history, it's guaranteed.
Yes. So anyways, person may or may not win. But it's close to fair, right? Expected value is near 0.
So fair is 0.
Yes. 35. Let's see what 35 is.
Oh, we're done this test.
Thank you for sharing.
All right. A drawer contains an unorganized collection of 50 socks. Okay. So again, if I do my sock drawer, yay. I got a sock drawer. I got 20 are red and 30 are blue. Okay. And they're unorganized. That means they're all mixed up. And then they say what? Suppose the lights go out. So Kathy can't distinguish the color of the socks. And she doesn't have any night vision with her. It says, what's the minimum number of socks Kathy must take out of the drawer to be sure of getting a matching pair?
2, the minimum. Because then you can get 2 and get lucky.
I'm just trying to figure out how she can't see it when he's
Don't overthink the problem.
It got me 2 though,
Just-
because
Hey,
you can get lucky and pull out 1 and the other one matching it.
You could get lucky.
So that would be the minimum.
But I could end up pulling out what?
50.
What's the possibilities? I could pull out 2 red,
You can pull out anywhere between 2 and 50 socks.
right? But listen, I can pull out 2 red.
A red and a blue.
Devin, are you listening? 2 red, or 2 blue, or red and blue. Is just pulling out 2 socks going to cover me?
If you have
If I still have that option of having a red or a blue sock?
if you pull out a master pair, then
If.
that's what it said, the minimum.
Yes, what's the minimum number that assures me of getting a matching pair?
Oh, that assures. You have to pull
Not-
out all 50.
Not 2. No, you don't.
Oh, 30.
I have 2 red, 2 blue, or a red and a blue. What happens if I pull 1 more sock? Do I get a matching pair? No, if I had a red and a blue pair on the first 2 I picked, all I need is 1 more and I definitely have a matching pair.
So 4 socks.
Okay? 3 socks. Okay?
So you know it's 3 because
I know it's 3 because I can have 2 red, or I can have 2 blue, or I can have a red and a blue. The next one I pull out, the third one, is guaranteed to be blue or red, which would give me, even if I had this, I would definitely have a matching pair on the next one. Okay? So the minimum is 3 socks. Okay? And that's minimum. Alright? B. We have to find B. I guess that's at the top of this page. So let's slide over. It says if 2 socks are taken at random from the drawer, Daquan, can y'all not have your own conversation and pay attention? Because you do have a test tomorrow. If 2 socks are taken at random from the drawer, what is the probability that they make a matching pair? You're just choosing 2 socks, guys. Did we just do the sample space of that?
Yeah.
So 2 out of, that's my sample space. 2 out, not 6. 2 out of 3. There's going to be 2 out of 3. Okay? Because it could be red, red, it could be blue, blue, or red, blue. And these 2 match out of the 3 possibilities. Okay? On the 2 socks being pulled out. And guys, they did do this problem different. And what did they say? The 2 socks are taken at random from the drawer. What is the probability that they make a matching pair? They're getting 0.51. Okay, and I disagree with that. Because yeah, if they're only taking 2, that is your sample space.
It would be 50. You only draw. I don't know. It's on.
I see what they're doing. I see what they're doing. Guys, I oversimplified this for this piece here. Because this probability and this one are 3 different things. They're not equally possible. Do you see that? Y'all see that? If they were equally possible, this would be true. So what you want to do is say, what's red, red, or blue, blue. That's what you're doing. Okay? It's not really 50-50 either. How many total possible combinations of socks are there in that drawer?
Oh, jeez.
The order doesn't matter because a red and a red sock or a red and a red sock are still the same two pair of socks.
3.
So I'm doing 50 total socks in the drawer, taking 2 at a time. Okay? How many possible, Ricky, Daquan, can y'all please pay attention? Again, you have a test tomorrow. Okay? Guys, if I take this right here, 20 red, then I have the combination of taking 20 socks 2 at a time. That would count up my favorable outcomes for those red socks. Okay? I do the same thing with my blue socks. That's 30 taken 2 at a time out of a total possibility of 50 taken 2 at a time.
How you put that in calculator? I'm sorry.
The same way. If you want to do the alpha y equals n over d, then I can do my what? 20 math, left arrow 2, 2. On top, I can do my 50 math, left 2, 2 on the bottom. And then I can add to that alpha y equals n over d again. And then I do what? 30 math, left arrow 2. And I'm doing it wrong because I'm doing NPR. Let me back up. Alpha y equals, and y'all be careful on your test. Don't do what I just did. We're doing combinations and I'm typing in permutations. Okay? You saw that, didn't you? You say something to me. Don't let me keep being stupid. No. I'm not getting the right answer and be wondering why. Because I'm typing it wrong. Okay. So I got 50 math, left arrow 3, 2, and then we're adding to that alpha y equals n over d, and then I can do my 30 math, left arrow 3, 2. Oh crap! I hit go to or hit enter too soon. You got to use the arrows to move around, not enter. Enter says do the calculation. So this one's going to be 50 math, left arrow 3, 2, and then that's what we have written here. Okay, so we're going to take this and just hit enter, or I can hit the right arrow to get me out from underneath and hit enter, and we get 25 over 49, which is approximately what, if I convert that to a decimal, it's about 0.51. Okay, if I round that. But again, on your test, if you got 25 over 49, I would leave 25 over 49. Just leave it as a fraction. Okay. Some of them I think you can enter either. Some of them I may require you to enter a decimal. So whatever the case, just do that. And I think the last one we're doing, guys, is 37. It's 1034. Okay, this is a zip code problem.
Oh, God.
How many different zip codes are possible if they consist of 5 digits? Again, what kind of problem is this? I have 1, 2, 3, 4, 5 digits. That means I have 10 possibilities, 10 possibilities, 10 possibilities, 10 possibilities. And what do I do with all these? Multiply them together, and I get 100,000 possible zip codes. Okay? And then
So that's what I
B.
was thinking, like when you were putting in the calculator, I thought you could do something like that.
And I hope you understand when I said the 2 out of 3, that's only if those are equally likely outcomes. But they're not. Okay? Which is unfortunate. All right, B. How many different zip codes can be read when the envelope is turned upside down? And upside down 9 is a 6. And 0, 1, and 8 are the same when read upside down.
Wait, what?
This is stupid. So using those.
I agree. This is a stupid problem. But it is a weird problem
You're not
to try and
gonna
figure
give us
out.
anything like this on our test, so
Hmm?
you're not gonna give us nothing like that one on our test, so.
I don't think so. Definitely not.
9, 6, 0, 1, and 8. So you gotta use those to make the 5 digits.
Okay, so if them are the only numbers you can read.
So you have 5 options.
It's not
5,
Yeah, we have 5 options.
5
It'll be
times
5,
5.
5, 5, 5,
5 times 5 times 5.
Really?
5 times 5.
right? Would it be that way?
That's what you think? That's right.
For real?
Oh my gosh.
Lying to me.
I am not lying. You are so correct. Oh my gosh.
Hold on.
You did that so much easier than I did yesterday. I had to think about this. But you're right. You knock out the possibilities because the 8 is the same as the 8. Do you see what I'm saying? So yeah, you're looking at 5 times 5 times 5 times 5, which is what? 3125 if you multiply that out. Wow. I like that. All right, so if I look at C, what's the probability that a randomly chosen zip code can be read upside down?
You gotta do the multiplication first.
Did you already do it?
Oh, wait. Oh, a random one.
How many are read upside down?
I mean, 3,000.
How many total possible are there?
They both are.
And reduce that.
You have to divide it by 5. So, of course.
Yeah, it's just 1 over 32. You can reduce that on your calculator. Just type it in, convert it back to a fraction, and you're good to go. Okay?
You shouldn't put my own calculator.
D. How many zip codes read the same upside down as right side up?
Well, wouldn't you just do the ones that you could read upside down over the
Yeah, that'd be the same answer as the one that you can.
Oh, I didn't even do this one yesterday. How many zip codes read the same upside down as right side up?
That's the same as answer B.
The same as answer B. Or just take the probability times 100,000, which is what you just said. Okay? That's probably why I didn't write that one down yesterday. Guys, number 39. Wrap my head around this one.
Let n equal 3,600,000. N is 2 to the 7th, 3 squared, 5 to the 5th. How many divisors does n have? A divisor is things that divide into it evenly. Okay? How many even divisors does n have? And how many divisors of n are multiples of 6? What is the probability that a randomly chosen divisor of n is even? Okay? I got to think through that one some more because I tried after school yesterday and obviously we had to get our calculators together. I did not finish thinking through that one, nor did I think about it last night. So we're going to skip that one for now, and no, I'm not going to throw something like that at you on the test, okay? But that one's going to take me some more thought too, okay? And again, this is more of a challenge problem. Most math texts, when you get to the last problem or 2 or 3, they were always the challenge problems. You know, they were the ones that, they're not so straightforward. I do have a suspicion on this one that you're going to be doing distinguishable permutations on this. That's my guess, but I don't know. That's just in the back of my head when I read this problem.
But anyways, we're not gonna worry about that one right now. Guys, it's 10:40. I haven't uploaded the other video yet. Do you want me to try and play that one, or do you want to watch that one at home tonight?
Play it. Play it.
Play it. All right.
My internet's been sketchy.
All right. Well, what I need to do is I need to stop the video on this one.